Once again, good evening to all the participants. So let's start with the session 4, that is on LLMs and engineering and research driving innovation in automation and problem solving. Today we have with us Dr. Asif Afzal as a session speaker. Dr. Asif Afzal has 11 plus years of teaching experience and 8 plus years of experience in research. He has published over 170 SCI indexed articles, more than 22 Scopus indexed articles, and he is a fellow member of Inventive Research Organization India. He has editorship in 7 different journals. He has obtained fundings for 3 projects, and he is one among the top 2% highly cited researcher in the year 2022, 2023, and 2024. He currently serves as a faculty and postdoctoral research in the University of Luxembourg. It's so honored to have you as our session speaker, sir. A very warm welcome to you. You can proceed with the session.
Thank you, madam, for your kind introduction.
Thank you, sir. You can start with the session, sir.
Yes, ma'am. I'm sharing my screen now. Yep. Okay. Uh, Good evening, everyone. Actually, afternoon here. Good evening, everyone there. I thank Datamites team and SPG Institute of Technology in Bangalore there for inviting for this session on LLMs in engineering and research. Myself, Asif Afzal, and I'm working here as a faculty member and postdoctoral researcher. I'm working here past 3 years and working on a European Defense Agency project for different simulations basically. Okay, now let me go to the slide. Okay, let me tell you what I'm going to cover in today's session on LLMs here. Basically, the fundamentals of LLMs, which I think the other speakers have already covered this one, and the capabilities, of course. But it will be a perspective in engineering and research purpose in automation and manufacturing side, how it is applied in research for literature review, for the analysis of the data what is obtained, and overall for writing purpose. Related to the engineering aspect, how it is used for design, simulations, drawings, manufacturing purpose, in supply uh, chain management, total quality management, biomedical field, robotics, automation, those things we will cover up in this one presentation here. I will also give an example of the research works, open research works, which have been published, well documented related to these fields, and those review articles which have good citations. Only those articles I have referred. And let me clarify one thing that most of the illustrations are all generated by AI here. I have used LLM for these illustration purpose because the session is itself on LLM, and so I have to reflect the capability of LLM generating these illustrations. Particularly, I have used a napkin.ai where you put some uh, content, and according to that content, it will generate the illustration. Okay. This session will be like moreover like the status of LLMs, how they have been used in the past, where they stand, and the future, what you can expect from LLM. So most of them might have already used extensively these LLM tools. Few might have used less, and few might have not at all used. So in this session, we will cover till now what is update, and in different field of engineering and research, how it has been used and implemented for and for day-to-day life purposes. I'll not focus much on the basics and fundamentals of LLMs, which I hope which might have been covered by the previous speakers. Basically, LLMs, the explanation of LLMs needs a proper session for that one, how they work, what they are, their fundamentals, not in the scope of this today's session generally. So LLMs are dependent on this neural networks, transformer architectures, which have already been trained on huge amount of data. You know that there has been a lot of discussion on these data centers which are located in highly advanced or tech-based places where they use tons of electricity and massive cooling units, which have raised the concern of environmentalists, which is real threat. No one can disagree on that one. So that kind of huge amount of data has been trained on those data centers. So they generate human like text responses, which we all know. And there is no limit for the parameters that it has been trained on, and how much information has been fed to them, and every day how much information is being fed in terms of a user as well. So there is no limit to that one. It is in terms of trillions and trillions. So the LLMs, now let us come to the capabilities and their roles in different fields. You can see this on the right hand side, the figure what it has been generated by Dali, and I have given the citation at the bottom there. So these LLMs, they offer ways to automate and speed up our analysis, our charts, our design, our writing, literature review particularly. And they have the potential for every single field. In some field they have the highest ability, they have proven their capability in some fields. In some fields they are still growing, and in some fields they are super slow. More or overall we can say that these LLMs are really helpful in day-to-day life, particularly who are in the engineering field and who do a lot of intensive work on the system. For them it is of super useful. Even for a layman who doesn't know what is engineering, who is not from any technical side, but if he knows English language, then he can make use of this LLM specifically in a optimized way for his uh, day-to-day problem solving and understanding what's going on, and to gain the knowledge. It's super easy for him as well, not just engineering side. Okay, they have the ability to process the data, and in the field of electronics, robotics, you can say in fluid engineering, in total quality management, robotics, supply chain management, cost control, quality control. Mark, there is no limit for that one. You can see the figure that we have, that has been summed up here. One thing is that LLM cannot replace domain experts. LLM itself needs a domain expert. It needs a guidance how it will give the result, where it is going wrong. So there is no replacement for domain experts. So they can act as assistants, but they cannot act as a domain expert. They will provide us help in many things, but they cannot be an expert in that area. They don't have a limitation like they can generate tremendous amount of text, codes, figures. They are machines. They can do um, infinite amount of work, but there will be some errors involved. There will be some mistakes involved which you have to go through. You can see in the chat GPT that whenever it generates the output, it mentions that chat GPT can give wrong information or data. It has to be verified. So they are not even accountable for that one. They will just generate the data on what it has been trained, but they're not accountable for that one. Believe me, this one LLMs, they are super helpful in reading the documents. If you're applying for literature review is a separate aspect. If you are going through 2 3 documents in on a website and they have slight differences. For example, if you're reading if you want to submit a proposal and they have different schemes, and you want to know what is the difference. Earlier what used to be download and we read go through everything. Even still it is confusing, and then we contact them to ask the doubts and those things. It took a lot of time for us. But nowadays you feed both the PDFs, three PDFs, multiple PDFs, and ask the difference between each PDF, then obviously it will clearly, very clearly, in a layman form, it will tell the difference between these schemes, these grants and fundings. So it is so super easy for us nowadays to find out the differences easily. It will summarize the text whatever is there in that one, and it will also tell us where we have to be careful, what are the conditions to apply for this funding, blah blah blah, and those many things. Coming to literature analysis, here researchers are really blessed nowadays. Those who have those who have started doing their PhD, those who are doing initial research, even they are in the masters, or any established researcher. If he wants to do a literature analysis nowadays, it has become so super easy. I remember when we started doing our research, that time there were Google Scholar, Sci-Hub, LibGen, many websites are there where we get the data, but we have to manually search the files and the sources where we get the data, where the publish I mean the where the research work is documented. There was no limit to the search. I mean, we have to keep on searching. I remember months together we just used to download the PDFs and collect, make their folders, categorize them and read them and read them and read them and keep on downloading. And our supervisor used to say that literature review is a lifelong process. Until the completion of your PhD, you have to keep on doing the literature survey. So it was so complicated during those times. But nowadays you have so efficient tools like lit maps is there, biblio shiny, you have scispace, perplexity. There are I mean numerous number of tools which will help you summarize the articles, the published work in conferences, journals, in preprints, on different websites. So it will collect, it will summarize, it will give you the everything in even in the form of a beautiful chart. Different countries from it can summarize you the locations and how many authors have done in which field. I mean, Biblioshani particularly, it is super impressive for this literature analysis. It's a publication in our language. It is there, that library. So literature analysis nowadays is not more than a week task. I give one task of literature analysis last week to my one of my master students who is working there in Toulouse University in France, and then within 1 week he came up with a review article. So he didn't know many things in that one, but I had to train him. Within 1 week, how did he manage? He managed through this AI tools, LLMs, where he collected all the articles. Initially, when we started doing the literature analysis using these LLMs, the citations were not correct, the links were not working properly, the text it extracted was not good. But nowadays, it is super awesome. I mean, it can be used nowadays, but we have to make sure that we have used AI in the literature analysis, and we have to humanize it. We have to cross check the content what it has generated. We have to verify it. Without verification, it is not authentic. So, and if you want to generate an idea, you can feed the links, or uh, if uh, if you want to generate some, if you have some rough idea, and if you want to narrow down, so from your thoughts it can narrow down, and it can guide you for a beautiful example. It can refer to the entire data set and refer whether the work has been done on this or not, how you can modify, and how in the future can this work can be done. And of course, those who are in the field of computations, they know that LLMs are super efficient in generating the codes for analysis purpose and for simulation purpose for many things. As I said, for a literature survey, there are different tools nowadays which can be used for automatic summarization of the literature review. It is not just summarization or collecting the data or not making the review article. There are few tools which will collect the data for you, and it will convert them in the form of audio, text, in the form of audio to you, so that you can listen to it. If you are not feeling comfortable to read the text what it has generated, it will convert for you in the form of audio. So just like you listen to the audiobook, you can listen to this one. You can convert the entire uh, PDF into audio where everything is read line by line, or you can also make a audio in the form of a conversation where the question and answer session, the questions and answers related to that particular research from that particular published article will be generated by the LLM in the form of a conversation. One will be asking the questions and the other will be giving the answers. So to make more interactive, this kind of conversation audios are also possible in LLMs nowadays. Nowadays, because the publication is either the author has to pay, and the reviewer, he doesn't get any credit for that, or neither his name comes up, or nor he gets any payment for doing a review. I mean, basically the reviewer is anonymous and he has to do the job freely, whereas the publisher gets tons of money in dollars, 4,000, 3,000, $5,000. So most of the time what reviewers do is they use uh, these LLMs to review and give some questions. So nowadays, our articles, when we see the comments, we can easily understand that okay, this review report is generated by LLM, and the reviewer has not done his job. We are not here to blame the reviewer because he has his own problems. And nowadays, even I have also stopped reviewing because it is just a free job, and no one acknowledges the work there. So reviewers have started using LLMs to review the article, and within few seconds they generate the review report, excellent review report, which has to be verified most of the times. And they have the ability to do a lot of computations and generate even libraries, even fields, and link them, also couple them together. An article by Shen et al. And he has, I have given provided the link here. He has well described how this LLM helps us in AI, and how it automates the literature survey. So please go through this link, which I can also share this link um, in the peer review process. Coming to the writing part, in the scientific writing part, there are few tools which are used as a plugin in Overleaf and also in Word file. So when we write a research article, we go out of, I mean, we run out of words. We don't find technical scientific words to give the explanation. So what this plugin does is that if you ask to assist you, so for that particular graph, it will pull up all the related articles. It will provide you the scientific explanation, technical explanation, why the trend is like that, what is the scientific reason behind that one. So you can use that text and you can humanize it. It is perfectly authentic, you can use that one. It will also generate the citation for you. In that case, it can paraphrase. If you copied something from some PDF, and if you want to paraphrase, that tool will also paraphrase the content for you. It can elaborate, it can simplify, it can do multiple things. So in writing an article, that particular tool is also very helpful, those who are using Word file specifically. Yeah, LLMs, they are excellent in interpretation of data in the form of CSV file or text files, or just you copy paste the text, and in the prompt itself you give, it will understand, it will analyze the data. You can feed an Excel sheet, you can put it in the form of image, the data, so it will extract, it will understand the data from the text, from the image as well, and it will do a beautiful analysis for you, and it can convert that chart in that data in the form of a chart, in the form of a graph for you. So generally what we do, we spend a lot of time in plotting. We use some tool like origin plot, or we use Python, we use R, we use Excel, and GNU plot, many things to plot a figure. But if you have data and if you just feed it and ask it to plot a graph for that one, You don't have to do any manual work. It is completely automated, and the LLM will give the chart, the graph directly to you. It can also read the figures from the PDF from the thesis, and or you can feed some figure to you, and it will also generate the reason why the trend is like that, why the what the figure says, and how the results are varying. It will do micro analysis to you, which humans take a lot of time, and it will give you the results in fraction of seconds. Now coming to engineering design aspect, we can ask LLM to generate a specific model. You can input your conditions, you can give your parameters, and it will take care of all those things, and it will generate a rough design which has to be verified again, but still it will give a blueprint of the design which you can go through, which you can modify, or you can ask itself to do the modification. So it will modify as per your needs and again regenerate that idea, and it can create the model itself, not just the idea. It will not just the blueprint, it will create the uh, a model which you can use in other softwares like ANSYS Fluent, like Abacus, MATLAB, where further analysis you can do it. But what I'm saying, trying to say is that earlier these models we have to spend weeks together to do their drawing and make the model out of that one. But LLMs are capable to do this modeling part. They are enough. They get integrated with the CAD, the CAE, and design themselves. That's what here I have provided you. That they are also good in collaboration or hybrid kind of expertise, where LLMs are good in generating the reasoning implications analysis, and the other tool like CAD or CAE will give you the expert modeling charts. This was this is from a published work where you can see a figure on the right hand side. This LLM has generated the exterior and the interior of the car. It will show you how the design is sleek and it is modern, or which looks like a fictitious thing. It has given a excellent model with keeping in mind the features like external design, what are the color schemes, how the wheels, how the brakes, how the what will be the material for this vehicle. And if you want to change the material aspect of this one, it will also give you the physical capability of those materials, which one is good, which one is not good, which has this ability, whether in for the given condition, for the stress conditions, whether this material will hold or not hold. All these characters it will consider, and it will give you, modify you the design of the vehicle. So multimodal output is nowadays very common, where the design aspect is taken into consideration, the architecture is taken into the consideration, the infrastructure is taken into the consideration, and it will hybridize. It will make hybrid of this one and give you a super awesome output related to that one. But the condition is that it has to be re-verified. So generating these kinds of 3D models directly from LLMs is a super easy task, and it will save a lot of time for engineers. Among the entire, um,
Sushrut,
so
Sushrut,
among the
కనిపెడితేను
so among the entire thing, what I have gone through different research I've done. Uh,
I thought I'm getting myself a gobi manchuri.
okay,
And
someone can you please mute yourself? Okay, thank you. Um, so if you see here in this one, in this figure, there is a plate with four holes and the corners have been rounded off. I remember that when we do this kind of drawing in any simple software, it takes at least 5 to 10 minutes for an engineer to um, um, make a 3D model of this plate with holes and corners rounded off. But you see, when you give a prompt writing a plate with four holes near each corner and rounded corners, super awesome result. It has given 100% perfect result. It has given with the holes being chamfered, not just the corners being rounded, but the holes are also chamfered, which is the precise thing what an engineers need. So this kind of CAD modeling or engineering capabilities of LLM are, I mean, it's so helpful for the engineers. It is so time saving for them, and not just they develop this model. They will output this in the form of a script. If you want in the form of script where you want to further modify them, you can modify them and feed for your simulation for the simulation or analysis, and it will also uh, in the form of APDL it will output, where this APDL format will be used in ANSYS workbench for finite element analysis further. So this kind of analysis have been tested and well documented in literature, which you can refer so easily and you can try by yourself. Yeah, that's what. One is the CAD aspect, and the other one is the APDL aspect of this LLM. MEC-RAG is LLM based tool developed for mechanical purposes. So where they integrate this CAD and engineering data into the LLM, and then this LLM get super trained with high accuracy in these parameters, which will generate either script or the model itself directly. So engineers now can interact in natural language, how we speak, how we understand, how we talk. So it will help to build the prototype, and it will help in these scenarios for building the prototype, and as well as doing the simulation of these prototypes in CAD for CAD engineers. In mechanical engineering design, if you want, this is the simple aspect what I'm showing you here. If you ask to, okay, you give me a 3D model or design of a car, aeroplane, tractor, bike, ball, anything like that, it gives super awesome, excellent results like this one. It is purely generated by LLM. It is not extracted. It does not copy from some source and give us here. It extracts by itself, where you can ask to have particular color of the car, the size of the wheels, and whether it is a SUV, sports car, or it is a race car. So just giving one prompt in 2 sentences, it will give you the output pretty fast, and which is authentic, which you can use. So in this simple kind of analysis, mechanical engineering design, which you say, it is super good and proven already. Even for statistical analysis, where we add up all the vertical forces, horizontal forces, lateral forces, and sum up to zero. So this kind of statistical analysis are super simple, where we try to equate all the acting forces and the reaction forces. We try to sum up all the moments acting at a point, and we equate to zero, and then we do the analysis and check whether the forces acting as whether the structure is stable or not. So such kind of civil engineering problems where the statics are involved, it is super easy to solve. But when it comes to dynamics or complicated issues, problems, this LLM, they don't, I cannot say they fail, but they don't provide the results efficiently. Those who have used it for mathematics based um, assistance, so for simple kind of issue problems, it gives proper answer, but for complicated mathematics based equations, like for FEA based equations, or fluid flow based equation, or drug flow, or chemical evolution, chemical reactions, there it becomes complicated for it, and it most of the time it doesn't give the accurate answers. So in those cases, humans are still needed, expert domains are still needed in those aspects. And this is one of the wonderful things, achievements of LLMs, what you can say. In Netherlands, Delft University, um, they asked the chat GPT to design a robot basically for tomato harvesting, because you know that there is a shortage of labor, and they try to do all the most of the work in their field by themselves. You might have also seen how the automatic robots, they are used for gardening purpose. So for picking up the tomatoes, they have asked chat gpt to do a modeling of a robot for this tomato harvesting. So you know that we as humans have some limitations when we think. Sometimes you go out of the box, but sometimes we miss some data, some aspect, whereas whatever data it has, the LLM it has in its whatever data it has in its database, it will go through at once everything, it will refer there, and it will try to come up with all the aspects and on the table. So the design what ChatGPT provided was a little bit enhanced than what humans, the researchers thought there. And the ChatGPT identified that in the design it has some lacunas, some drawbacks. Example, like the robot what they designed has the issue with crushing the tomato. When there is a tomato on the way, it doesn't identify that, it just crushes. So that aspect was taken care by the LLM ChatGPT, and then they designed a super excellent tomato harvesting robot, which we can see on the right hand side, and I have provided the link here at the bottom. So this is a case which was published in a news. So LLMs have this capability in automation and robotics as well. Now, these LLMs are also good at identifying objects. Initially, when the ChatGPT was developed, you might have seen that it was just capable to take the text as input and give the text as output. But now it has super been developed with deepfake also on there, and many other LLMs in the market. You don't have to just give the input in the form of text. You can also feed it as directly image. So the computer vision part has also enhanced so much that from the photos itself, it will understand what it has to do. If you want to identify the objects, it will identify for you. If there is any command in that one, it will take it as a command. It will identify the command, and then it will uh, do the task. And while doing the task, if you need something out of that one, it will keep track of that tasks, and it will modify based on your need. And if you're not satisfied, it will keep on designing that output, and it will keep on improving every time you ask. But sometimes it will not just refer to our conversation, it will go to the database, and it will try to fetch data from that one. That's why sometimes the design may vary a large at some instances in the outputs. So we have to carefully advise the LLM what it has to do in the next output. In the manufacturing process, it is super useful, no doubt about this one, because LLMs, they give the logical reasoning, and they can refer all the logs, all the files, and it can keep track of of the issues, or the troubleshoots, or any variations. It can keep track of the outliers, at what instant, at what position it has happened. So in the manufacturing side, LLM have been super useful. Many industrial multinational industries have started using these LLM in their manufacturing aspect, which has saved their 30 to 50% of the time in most of the time. And in industries, sometimes they need super simple codes, which takes some time for the engineers to develop. But LLM is so efficient that within seconds it will understand what they want to develop, and it will give the code, not in just form of Python or R, it C, C++, PLM. in all the formats it can give the code super easily. So here in manufacturing process, if you need anything related to generating a test or analyzing any logs or the data from the sensors, or planning any manufacturing process, or inspecting or analyzing the process, it will be super helpful and super useful in these aspects as well. Now we will do some case study analysis, which has been well documented in literature. MEC-RAG is a kind of mechanical based LLM tool integration, or you can say hybrid tool, where in that one, all the designs related to mechanical. Here, CAD is not just the engineering drawing. It can be in the form of photos as well. It can be in the form of 3D model. It can be drawing. It can be script form of also, because we have some tools like GeoMesh, where we don't have model itself. We have the scripts in the form of C language. So that complex models and mesh and boundary conditions are also fed to this hybrid MEC RAG LLM, and then it is also fed with a lot of tables and charts where it has the data of the machines of the different parts. And now during the process, a user can ask what is the tensile strength of this one. It will give the output. It will fetch from the database and it will give the output very super fast. So you don't have to do, you don't have to run a program for that one or do manual searching. It will not just fetch that one, it will also tell you whether it is exactly fit for the process or not. So the user can then take a decision whether it is, and he can verify whether it is suitable or not. Then he can suggest, he can ask for the most suitable material which has so and so tensile strength. So ILLM can speed up, accelerate the process of decision making. And these model files, manuals, when they are populated and they are embedded,
Voice not audible. Uh, Sir, your voice is muted.
Hello, sir. Sir, hello, sir. Asif, sir. Your mic is muted.
Yes, his mic is muted.
Hello, sir. Asif, sir. Sir, are you there? Are you there, sir?
I think our meeting end ಮಾಡಿದಾರೇನೋ.
ಹೌದಾ?
He's there, he's there, he's there. His mic is muted. Sir, you are on mute. Asif sir, you are on mute.
You said hi in the chat.
Hello, can you hear me now? Hello.
Yes,
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 sir.
sir.
I'm sorry, I don't know why it got disconnected. Shit. Okay. Oh, where is okay. So in a mechanical field, the scientists have been developing specialized agents which is specifically focused on a particular domain like mechanical, and they take the help of LLM to automate the process. I love this particular computational engineering part, how LLMs help computational scientists. So here in our university, we have a supercomputer, and whenever we uh, upload our code and we try to run it using a script, most of us sometimes it fails. Why it fails? It fails because sometimes uh, on the HPC, on the supercomputer, they upgrade the communication system. Sometimes they upgrade the libraries. Sometimes our the user data might get changed, so they upgrade the system itself. Sometimes maintenance is required. So many things keep on happening. So we did face these issues every month, and the HPC team also, they communicate everything with us, and they also uh, provide all the relevant information on the website. And to exactly read and understand it, it will take sometimes half a day, 1 day, 2 days, 3 days, again reaching the HPC team for understanding the problem and trying to solve it. But nowadays, just whatever the error comes, copy paste in the LLM, it will understand what issue you have. You don't have to explain the problem also. Just from error itself, it will understand what problem it has, and it will solve the problem for you, and it will tell what has been changed and where in the script you have to modify your changes. So this has now saved particularly our time a lot here at the university. So in the computational part, if you want to do a parallelization of the code, you just provide the code and it will wonderfully tell you where you have to insert the commands appropriately to parallelize your code. No doubt about data analysis, it will do the super data analysis. There is also called as deep search aspect in ChatGPT, which you can use if you have a paid version, and it will take some time, but it will dig throughout all the content. There might be some IP related issues. There may be some data breaching problems with that one, which you have to be careful at that point. But it will dig into a lot of aspects, and it will give you excellent results, and it will do the particularly data analysis is super awesome in LLMs. And as I told earlier, that LLMs are now being integrated with different softwares like ANSYS Fluent, Abacus, Star CCM, MATLAB. These are all the tools which we use in our field. So now LLMs have been integrated into these tools so that even the user has a super easy uh, method to automate his simulation. In mechanical engineering, it is a domain specific LLM. There are a few tools that have been developed now, and there is a company called as Leo, which works on purely AI based mechanical assistance. And this Leo has genuinely supplied mechanical data to LLM. It has trained only the specific and relevant authentic data to the LLM on different parts in different domains of, I mean, different subfields of mechanical engineering. So I have provided you the link here at the bottom, which I can share you later. and you can see how this has helped in increasing the accuracy of the LLM in mechanical engineering field. So if you query in the common language, okay, go and find me this kind of nut and bolt, a kind of bearing or a joint. So it will accurately find out the required design for that one, which will save a tremendous amount of time. SolidWorks is a tool in mechanical engineering field which is used for modeling and simulation of mechanical parts. It is a huge software, but what LLM has been providing for us, so SolidWorks is behind that now. So this Sikot Bernard, he is the one of the operating engineer in SolidWorks. Says that this has caused a massive disruption in their product because these huge software industries, they spend millions of money to keep on developing, enhancing their software tool. But LLM has caused a lot of disruption in development of these works because it is able to provide you the model and do the simulation. In aerospace industry, you can see I have provided you the screenshot of the input and output from the chat box. So suppose you have an article from physics of fluid. Physics of fluid is a highly high impact, a very established journal related to fluids. So in the fluid, there are too many complex mathematics and physics involved. If you take a particular paper out of that one, and if you ask LLM to identify the different situations, the scenarios, what has been analyzed, it will first summarize all the cases one by one. It will tell you what were the parameters, input parameters, and what was the analysis done out of those cases. And then if you want to run those cases, if you want to um, do it once again from your side, then it has its ability to run that case for you. Now in OpenForm, what we do in OpenForm is a one of our software which we use. It has different fields. So every time you have to change a case, then you have to go into the field. You have to modify manually. For to modify it manually, you need that expertise where you have to modify it and what exactly those models mean. But now LLM can automate itself. I mean, it can automatically go to the file. It will modify those commands automatically, which is in basically it is in the form of C++, and run the simulation and give you the analysis of the result over a airfoil, which I have shown you here on the right hand side. So it will summarize the PDF file. It will tell you what were the cases that have been analyzed, what are the situations that it analyzed, what results they got, and if you want to reproduce the results, it will automatically build the cases for you, provided that you have that software on your desktop, and then it will tell what modifications you have to do. It will provide the commands for that one, and once you have that one, you can run those cases by yourself, and you get excellent results. And this open form, it required some training initially to understand and how to run the cases. But when I started using LLM, no training was required for me because ChatGPT one by one it explains how you have to use the case files. You have Chat Civic as a hybrid LLM for civil engineers, where which works on RAG based thing. So for civil engineering, they have fed with all the codes, civil engineering standard codes, and their designs and their textual data. What you say? So particularly when there is a text involved, the accuracy is super high from the LLMs. So civil engineers can easily now get the design from them. They can ask the query, they can ask the code and related specifications, bylaws for that one, and the design parameters, the safety parameters, the maps, the GIF, the sensor related to the data from that civil engineering site. and sorry, and all the aspects related to it. So this chat civic, it will take the live data from the sensors, from the maps, and it will narrow down what are the requirements to have a design from civil perspective. For chemical engineering, they have Chem GPT. So this Chem GPT is a hybrid tool which comes from the chemistry domain and then the LLM, which has been integrated together. In chemistry, you have tons of molecular reactions. So we have to write a code manually to do the analysis of these series of chemical reactions. But in this aspect also for chemistry people, ChemGPT is a super awesome tool uh, which can understand the reactions, and it can give the logical explanation where the reaction is going wrong and what molecules has to be replaced to find a particular combination of compound. So the the LLM can also, this particular Chem GPT can also use the scaling laws. And if you have huge molecular data set, it will also show what will be the performance gains out of this data set, out of this molecular data. They will not just scale, but they will also um, propose you the reaction pathways. They will also provide you the best scenarios, the best processes to produce the molecular compound. And it will also tell you what experiment has to be conducted for this kind of molecular compound. But in some aspects, it is really worrying that we need to be utmost we need to take utmost care, because the molecular compound suggested by AI, or which you can say the optimized compound suggested by the AI, if you don't verify it, sometimes there can be a fire hazard. Sometimes there can be an explanation, because it is a chemistry related field. If you end up with wrong combination of chemicals, so it can be hazardous. Similarly, in other domains, you have bioinformatics, electronic materials and physics. Believe me, I mean, bio GPT, circuit GPT, and so on, where this LLM can be used. I have mentioned it specifically related to PCB layouts. And in PCB layouts, you have a lot of resistance, you have caps, you have chips. Sometimes this chip is manufactured in Korea, sometimes it is manufactured in Japan, China, America, India, somewhere. Don't know, because it is assembled. The resistance come from somewhere, the capacities come from somewhere. Um, so the glass comes from somewhere. So all this is assembled sometimes on the PCB, and the procurer is interested in understanding where exactly this has been assembled and where this comes from. The the logos, the markings will be so small that the procurer will not be able to identify those logos. But the supplier might have assembled it from different sources, and he tries to cheat the procurer by over budgeting him. So in this case, the procurer has to be very careful. In that case, the LLM helps in identifying the markings, the logos, the fonts, and it can elaborate and it can tell for exactly what the markings mean, what the logos mean, from where this particular part has come. This particular part, how much volume or how much area it occupies on the board. So all the details can be provided by this LLM in electronics field. In material modeling, I have used this LLM particularly for material modeling. It is not at par for this one, because the analysis is super complex. I told in the initial of my talk that um, LLMs are not good in solving complex problems. So if you have the complicated boundary condition, complicated mesh, or the equations are governing equations are too much extensive, then the output, the result given by LLMs is not correct. It needs fine tuning, and it needs tons of time to verify it. So in those cases, it is better to go by a manual programming method, which the material modeling engineers follow generally. In the case of bioinformatics, it is super helpful, LLMs, because in the bioinformatics the data is tremendous. I think the data is the highest in case of bioinformatics, because when they take a cell, there are billions of points in that one. From one DNA they have so many genes. From one gene, like if they take mitochondria has many genes in that one. From genes, they have this strip of data which is itself in terabytes, which has the information of the molecule. Every single detail is present in the gene of the cell. So the data generated by bioinformatics is super huge. So LLMs can help identifying a particular portion, particular molecule from that gene. It is super helpful. Engineering education, as I think in the previous lecture also, he has Sir Lukman sir has also explained how LLM are helpful in problem solving and designing the curriculum, um, explaining the stuffs to the students, uh, the updated knowledge, the history, preparing the exam, even analyzing the exam. And if you want the explanation as an expert level or a lower level, junior level, senior level, everything is provided by these LLMs nowadays. But there is also a risk that if you completely rely on LLMs, then you may end up becoming very lazy to learn new things and to use your brain, because every time using LLM can end up with your brain addicted to getting super fast and super easy results. So as a result, what happens is your mind becomes incapable of thinking. Critical thinking will be lost. As I said, curriculum development is there to check, to get the feedback, to give the gradings, to develop interactive virtual labs and learning and giving new ideas in different fields. It is super awesome. Not just students, even a layman who wants to learn in his own language, he can ask a chat GPT in audio form, and it will be able to give the output in the form of audio in the layman language. So the learning part has become super easy, particularly the history. Most of the time the information provided by with source is relevant. Whenever we ask for any information, we have to also ask for the source, because we can go and exactly verify from where the data has been extracted. In product life cycle management also, um, AI, LLM, they help, because in PLM most of the time it is um, text related decision making process. So you can make the orders, you can change the orders, you can generate the report, you can summarize the result, you can design the result, you can design the report, you can make the report. So in PLM it is super helpful. It will reduce all the manual time of documentation purpose. You can also refer to the eras innovator blogs, where they talk about the usage of LLMs in PLM industry. In ERP also they use a lot of charts and Excel kind of things. So in this ERP part also, this chat GPT helps in analysis, designing the models, forecasting, analyzing the risks involved in the total quality management also. It takes care of and the quality control it also takes care of. It can also generate the purchase order if you want. Not just purchase order, it can make a bill also, it can make a draft of the entire grant you want. So many things uh, LLMs can be helpful in the SCM and ERP systems. NASA tested recently the information provided by these LLMs, particularly the ChatGPT. Whenever the ChatGPT provides the results, it provides the result with super confidence. Here you can see that phi is equal to E is equal to 3. It has provided, but we know that phi is not equal to E is not equal to 3. This is not true. But such kind of information these LLMs provide with super confidence. So we have to be very careful with these kind of output, because we need uh, sometimes there will be some kind of data integrity issues, sometimes there will be an IP issues in those analysis and those designs, in those output. If you don't verify, if you don't have the expertise, and if you are going to fabricate that material, you may end up with having a wrong body itself, and you may end up with completely safety issues, or there'll be totally technical and economical loss for you. So we as humans cannot oversight the output generated by to believe the output generated by the LLMs. As LLMs are trained over the data, where this data comes from. If suppose, for example, there are 100 sheets and 90 sheets they have wrong results and 10 sheets have good results, so the output generated by LLM becomes biased, because the maximum data is not authenticate which it has used. So there can be sometimes biasness, sometimes there can be fairness. So if there is a biasness, then the output generated by LLM can align along one direction. So in that aspect, we have to be careful. The LLMs are not responsible. We cannot hold them as accountable for the decisions or for the interpretations or the analysis what they do for our inputs. Sometimes there will be an IP infringement if you do the deep research, and there will be data privacy issues as well. But there are very authentic hybrid tools like Leo's AI, which is for mechanical engineers. They have trained the LLM on their authentic mechanical engineering data. So such kind of LLMs can be used as they don't breach the data privacy and they don't have IP issues as well. Now, how it interprets whether it is reliable or not, it is still questionable. It is only reliable when it is, and it is such an expert who has spent his entire year on one thing. But LLM are based on the data, so sometimes the results can be wrong. It can be misleading. So we cannot rely on the data generated by the LLM, because it is a black box modeling basically, because it is a neural network based. So we know that neural networks are black box modelings. So we have to be a real careful in these cases. We have to test the output generated by LLM, and we have to do the validation of the results that it has generated. Multi-agent means like one LLM particularly trained on only one set of one domain kind of data, like civil engineering, mechanical engineering, computer science, bioinformatics, electronics, robotics, manufacturing, and like that. So these agents have one particular expertise. They are good at generating the output for one particular field, but you can combine these different agents together. And when you want particular model, that model, if it has electronic aspect, then the electronic aspect is taken care by the electronic agent. The physical structure part is taken care by FEA agent. The aerodynamic design is taken care by aerodynamic agent. So like this, all these different agents they combine together and come up with a solid model, which will help the engineers come up with a new prototype. It will do its initial analysis, different analysis it can do, and from the database and reports it can extract information and then uh, generate the result for you, and it will store this result in some case library, and it can also give you in the form of to the user as in the form of an audio. So this result will also be saved, and in the future when the user tries to modify the design, it will refer to the previous design and what lacunas are there, it can also do the modification, keeping humans in loop. I mean, in this LLM, whatever the output has been generated without the input from LLM, it will not generate. So this output will be generated by keeping human in loop. So in that case, the authenticity increases. The results will have more value. Now, particularly in engineering side, you can give limitations in LLMs. The LLMs will have the limitations. It will have bounding box, so it cannot think outside this box, and it has to generate the results depending on this bounding box. So it is super useful because sometimes if you want to do a design and if it gives a design which crosses the safety limit of the material, the tensile strength of the material, so it is of no use. So it has to give the output in a form where the engineering aspect is taken care of, the factor of safety is respected, the Navier-Stokes equations is not violated, the boundary conditions are not violated. So in the trend is of having hybrid AI where the symbolic part, the physics part, which has different mathematical models are referred. Once it generates the text, then it refers the physics, the physical laws, the mathematical models, and within that box, if it is satisfying, then only it is going to generate the results. So in this way, the accuracy of the LLM is going to increase. Of course, no one is not new to this kind of assistance that, okay, it will give a personal assistance depending on his nature, his understanding method, his asking method. The LLM will be trained for the specific human being. So that will be called as a personal assistant. So the LLM will adopt to that personal human. And suppose we have accumulated a lot of information knowledge by working in a company from 20 25 years, this entire experience has to be fed to the LLM, and this LLM acts as a senior AI assistant to junior engineers when the junior engineers join the industry. So if they face any particular problem, the LLM will refer to the expertise experience and give them the solution how this problem can be solved and how in the past it was solved, and giving continuous information feedback to the LLM. Of course, it tries to develop and it tries to enforce itself in the particular range. In biological field, this LLM can help. Now, currently, what happens is that a biologist, scientist in the biomedical field, he develops designs an enzyme, he gives for the development of the model, then he manufactures it, then he tests it manually, and if he wants to do any changes, then he does by himself. This is the ongoing practice. But LLMs can help in automate this process. They will check what is the output, what changes has to be done, they will do the changes. If they want human feedback in that one, they will have human feedback. They automatically design the enzyme, then they give them a robotic machine for the manufacturing of that enzyme, and they do the testing. The LLM will automate the testing process, and then if the results are not satisfying, then it will automatically modify. So if this information, if this data is fed, so the output will be influenced from the past data, and the design process will not only automate, it will become fast. It will become super easy. In automotive, in aerospace, manufacturing, everywhere, the industrial manufacturers have been spending millions of amount in digitalization. Everyone wants AI to be used in their industry, and different the governments here particularly, I mean everywhere, not only here, everywhere they are funding the industries, providing stipends to use AI in their fields. Okay, but all the AI is still in trial stage. People are trying, they are not successful, and they are continuously providing the feedback for the improvement. There are still a lot of challenges related to LLM. As I told you, there is a hallucination risk, data breaching, IP related issues, and LLMs, they don't provide precise calculation. Even if you sometimes ask them to do some factorial analysis, they end up giving wrong results. Their quantitative reasoning is relatively correct, is lower than their verbal reasoning. Their verbal reasoning is super strong, whereas mathematical reasoning is very poor. If you design any chemical related thing, or a nuclear thing, or automotive automobile thing, the safety aspect, it has to be taken care by the human being. You cannot depend on LLM. And of course, it is robust to outliers. It can take care of the outliers, and it will reinforce itself to remain in one bounding box. And human AI collaboration is definitely is going to be the next thing in the future. In digital twins, LLMs, like, they can continuously take the data from the sensor. It can interpret the result, it can identify the troubleshooting points, and where the where the results are crossing the limits, and it can identify, and it can change the design itself, and it can inform the user. And it will also not just take the data, you don't have to upload it on the cloud. You can have a small LLM agent which can act itself as a cloud, and then it can process the data, and live data reactions it can provide, instead of depending on an entire code where the processing time is too high but the cybersecurity issue remains the same. If you are using a LLM agent, and if it is hacked, and if some misinformation has been fed to it, so the output gets influenced by that one. In electric car, in electrical grid system, if you see that there is a live data coming from the grid. So if any upgradation is required, any um, refining is required for that, the LLM can suggest in that total chain. Agentic AI, like for a specific domain, specific field, you will have a specific LLM model. Integration of physical system is one which we are eagerly waiting to see how it integrates with the physical system, how it gets bounded itself to the physical law and provides the output within that, if it is satisfying the physical law. And text, code, CAD, sensor data, all these things are being integrated and getting analyzed from these LLMs. So there is a continuous LLM, this one feedback process ongoing. So it is a continuously learning process. There are a lot of opportunities because tremendous amount of time is being saved in the manufacturing industry, and there is a risk human has to intervene, he has to verify the data. The benefits are unmatched. There are practical applications of this one, but we as engineers are held responsible for whatever the output has been given by the LLM. And as a closing remark, I can say that, of course, they are not just powerful toolbox. They actually improve the accuracy of the model. They will provide super efficient models, and they can take care of innumerous things which humans cannot think at the same time. That's it from my side. Thank you.
Is it done, sir?
Yeah, I'm done.
Any doubts from the participants? Any
Any
questions from the
questions they can
participants, sir?
ask me? They can. Yeah. Thank you. Thank you to you. Thanks for the participants for being here.
Thank you, sir. I think one of them have raised their hand. Yes, please ask the question. Seema, someone raised hand.
It's okay.
Does anyone have questions? Somebody raised hand. Okay. If no
Okay, ma'am.
questions, we can conclude the session.
Thank you, madam.
Thank you, sir. The session was so informative. I hope all the participants make the best use of it. And thank you so much for being with us for this wonderful, very insightful session. So before we wind up, I kindly request you to turn on your video because for our documentation, we require a screenshot with the speaker where the videos should be enabled. Can you please?
Is it okay, madam?
Yes, sir. Yes, sir. Just a minute.
Yeah, yeah, okay, ma'am. Okay, sure.
Yes. Thank you, sir. Thank you so much.
Okay, ma'am. Thank you.
Thank you. I request all the participants to fill the feedback form and also to take up the quiz immediately after the session. That will be shared in the WhatsApp group. Thank you all. We'll meet you tomorrow. Thank you all.
Thank you. Bye.
Bye, sir.